This is Geometry 3.6a, talking about angle relationships, day number 1. Particularly talking about parallel lines. So parallel lines are two lines that do not intersect. They have to be in the same plane. If we have a line, we could name that AB. Line AB is parallel, so we use two slash marks, to line CD. They're parallel to each other. Perpendicular. Two lines are considered perpendicular. We could call that point B, call that point A if you wish, call that point C. If they're perpendicular, they're going to form a right angle. And if you form a right angle, then you make 90 degrees. But you got to go in that pattern. We have BA, you can call it AB if you wish, is perpendicular to CA. You could call that AC if you wish. So those are perpendicular, that's a perpendicular symbol. These are parallel, that's the parallel symbol. We're going to talk a lot about parallel today. And before we talk about parallel, we're going to talk about the angles that are formed when lines cross. So we have two lines, as you can see in all these pictures. And we have this line called a transversal. It's crossing two or more lines. A transversal is crossing two or more lines. When you cross two or more lines, you make these 8 different angles. And we're going to name several of those angles. Let's take a look at what we have here. Look at our line that crosses. Look where those angles are located. We have this angle up here. And we have this angle on top of this line. If we think about these as like intersections of roads, that building is on the same corresponding corner as this building. They're both on the northeast side of the intersection. That's called corresponding. Even if we were to turn it, those are called corresponding. They're both on the northwest side of the intersection. They're both on the southwest side of the intersection. Or they're both on the southeast side of the intersection. They're called corresponding angles because they're both on the same side of the transversal. They're both on the top side or bottom side, whichever way you want to call it, depends how the picture's drawn, of the lines. Those are called corresponding angles. And there's several different pairs of them. There's a pair there, there's a pair there. Many different ways. Look at these angles. If I trace out angle 4, and if I trace out angle 5, what shape did I just make? What letter? A Z shape. Notice that in between these lines, they're called interior. even if it was turned, those would be considered interior. They're interior no matter what. No matter how it's turned. So we're going to call those interior angles, but how are we going to describe where they're located? Okay, the center is making the interior part, but they're on opposite sides of the line. They're not on the same side of the line. They're on opposite sides. So we call that alternate interior. And they're going to make a Z shape. When you trace out 4 and you trace out 5, you'll see that it's making like a zigzag, a Z shape. This one over here, if you think about it, it's a little harder to notice. But you could call this an F shape. This one's kind of backwards and upside down, but here, this F is backwards, but it's more like an F. If you went this way, this would be your typical F. And those angles would also be considered corresponding. Let's look at these. We know that these angles here are considered interior. Those are interior angles. They're in between the two lines. No matter how you turn the lines, those are considered interior. So what are we going to call 1 and 8? Those are exterior. Now let's talk about their location. Are they on opposite sides of the transversal? Yes. So we call those alternate exterior. Now, unfortunately, if we trace out angle 1 and we trace out angle 8, that doesn't really make a letter. Okay, so we don't have an F shape to call that or a Z shape to call that. That doesn't make either one of those. Okay, so that one's a little bit different. Haven't been creative enough to come up with what shape that's making. Let's talk about this one. You know that in between the two lines, no matter if the lines are facing upwards or diagonal or sideways, those are considered interior angles. Do you notice that these angles are on the same side of the transversal? So they're not alternate exterior, alternate interior angles. They're not in that position. They're on the same side. So we call that consecutive interior angles. Notice that all our examples here, they all have different vertices. So we're not talking about a linear pair. None of these are a linear pair. They all have different vertices. None of these are adjacent. None of these are vertical. These all have different vertices. So let's flip our page over. and you answer there are several different pairs of corresponding angles. There's two different sets of alternate interior, two different sets of alternate exterior, and two different sets of consecutive interior. Pause the video, and you go ahead and try to write those in. Okay, you should have had some time to try to identify your corresponding angles. Angle 2 and angle 6. If you look at these, angle 2 and angle 6. So 6 would be right here, 2 would be right there. If we turn that, we have to flip that. And what shape is that? That's an F. It's an F shape. That's corresponding. Where is there another pair of corresponding? Angle 1 and angle 5. If you like to do that tracing thing, you can trace out angle 1. You can trace out angle 5. And if we spin it around, you'll clearly see the F. That's an F shape. Those are corresponding. All of these are going to make an F shape. Is there another pair of corresponding?
3 and 7.
3 and 7. So if we trace out 3, we trace out 7. This we'll have to flip over, but then we have our F shape. That's an F. Those are corresponding. Angle 4 and angle 8. Angle 4 and angle 8. That is a perfect F shape right there. No need to move it. That makes an F shape. So those are all your corresponding angles. Let's talk about what happens with corresponding angles if your lines are parallel. If your lines are not parallel, those are just the names. We talked about that over here. Lines did not have to be parallel. Those are just the location of the angles. Really, the location doesn't mean much unless the lines are parallel. Notice the arrows here. The arrows tell you the lines are parallel. So if two lines are parallel, if two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. We can test that by tracing out angle 2 and comparing that with angle 6, and we see that they are exactly the same. So in our proofs, we're going to use the words if parallel, then corresponding angles congruent. What I'm showing you is you can get rid of this whole transversal part. I'm trying to make it as short and quick as we can. If you have parallel lines and you're creating angles, you've got to have a transversal. What you do have to do, you have to name the angle. You cannot say if parallel, then congruent. Because there are angles up here that are not congruent. So if parallel, then corresponding angles are congruent. If you have parallel lines, then you've created corresponding angles that are congruent. That would be great. But this is as short as it can get. Let's try your next set. Let's look at alternate interior. Which angles up here are alternate interior, or making a zigzag? 6 and 3. We have 6. Well, I guess that's 3. And we have 6. And you notice that that makes like a perfect zigzag. Perfect Z. Those are alternate interior. The interior angles are in between the two lines. No matter how you turn it, those are still interior, still the Z shape. So we said angle 3 and angle 6. Is there another pair? Angle 4. And angle 5. Now for this to really be a zigzag, we have to, I guess it is a zigzag, but to make it a Z, the letter Z, we did have to flip it over. But it is a zig and a zag. Anyway, 4 and 5 are alternate interior angles. When we cut it by a transversal, notice that that 4 and the 5 there's your 4. If you spin it around, it's going to be the same shape as your 5. So they are congruent. As long as the lines are parallel, alternate interior angles are congruent. If parallel, then alternate interior angles congruent. You can use abbreviations for angle. You can use abbreviations for congruent. You need to write the word parallel. You need to write the word alternate interior. Sometimes we abbreviate with a pair of slash for parallel. I guess you could do that. Let's look at alternate exterior angles.
For alternate, could you just put alt for short?
Which ones are alternate exterior angles? Angle 1 and angle 8. And what other one do we have? Angle 2 and angle 7. Now, unfortunately, when you trace out 2 and 7, or you trace out 1 and 8, they don't make shapes. I mean, that's all they make are shapes. We don't have letters. We don't have F's or Z's in that situation. So alternate exterior doesn't quite work as well for us there. But remember, interior are in between the lines, so these are clearly exterior angles, and they're on opposite sides of the transversal, so we call that alternate. Alternate interior or exterior angles. They will be congruent if our two lines are parallel. If parallel, then alternate exterior angles congruent. And then our last one. Sometimes this is the trickiest one. What do you see here? which angles would be considered consecutive interior? 3 and 5, they're on the same side, they're both interior. Angle 3, angle 5. Angle 4, angle 6. Now look at what happens when we trace those out. That's angle 4, angle 6. We often call that a C shape. Okay, did we put that in our notes? This over here you could call a C shape. Even when it's backwards, it's like a C shape. Now it gets a little confusing if it goes the other way. That looks like an N shape. That's all right. Still a C, still an N, whichever. So if two lines are cut by a transversal, consecutive interior angles are what? Now this is a little tricky. We know that corresponding angles would be parallel. If the lines are parallel, then corresponding angles are congruent. Lines parallel, then alternate interior angles are congruent. If the lines parallel, then alternate exterior angles are congruent. But what do we notice about here? If I trace out angle 3 and I compare that with angle 5, are they the same? Definitely not the same. Now, if I look at angle 3, and I look at the angle next to it, what would we call that angle compared to 3? That would be its linear pair. That would make 180 degrees. This angle here is equal to angle 5. So 3 and 5 are supplementary. Can you identify other angles that are supplementary? Let's come back up and look at all 8 of our angles. What are other angles? They're pretty much either congruent or they're supplementary. Don't pick any with the same vertex, but can you find a pair of angles here that are supplementary? What would you think? Two and 8 have different vertices, and they would be considered supplementary, but they do not have a special name from us. But they are supplementary. Is there another pair of supplementary angles? 1 and 7 would definitely be supplementary. Notice that one angle is smaller. Well, that would be 7, I guess. One angle is smaller, acute, and one angle is bigger. And that's going to make supplementary in these cases with the parallel lines. What's another pair of supplementary angles? 3 and 5, definitely 3 and 5. Those are considered consecutive interiors. So they're part of the names that we've already identified. But what about ones we haven't named? 5 and 6, that's a linear pair. That's definitely supplementary. but those have the same vertex. We're trying to pick ones that have different vertices. So a number from this set and a number from that set. Which ones would add up to 180? We know that 2 and 8. Let's go ahead and show you that. We've talked about 2 and 8 already. There's 2. If I slide down here and pair it up, and 8, you see it has that straight line. They make 180. What's another pair? 2 and 7 are called alternate exterior, but what about 2 and 5? Angle 2 and 5 are also supplementary. 1 and 6 are also supplementary. This is going to come up in your homework. We're going to do a proof about this. Angles 3 and 8. Those are supplementary. They don't have a special name. We know that 3 and 7 are the same. We know that 7 and 8 are supplementary, so that 3 and 8 are supplementary. We would also know that 4 and 7 would be supplementary. All right, that's a lot of stuff. A lot of names, a lot of angles. Good job.